Here in this section, we have graphs of common functions. So the first one that we have here is constant function. I have this graph for f of x equal to c. So assume that here, this point, we have c and c is equal to, for example, 1.5. So f of x equal to c, we're going to have a straight line, and that is horizontal line, which is parallel to x-axis. So in this case, what we have, domain is starting from left to right. On x-axis, we have negative infinite. Moving to right, we have positive infinite. Our range is the single number c. So what we have on y-axis is the only point that we have is this point, and that is c. And this function is constant on negative infinite, positive infinite, and in this case we have even function. Number 2, square root function. So what we have is f of x equal to square root of x. Here we have this graph for this function. Based on what we have here, domain starting from this point. On x-axis we have 0. Moving to right, we have positive infinite. And here on this part we have bracket, because that is equal to 0. If we had, for example, something like this, and in that case we have to use parentheses because of having open circle, but this one is closed circle because it's equal to 0. And our range is what we have on y-axis, and that is, again, starting this point, moving on top, we have positive infinite. So it's from 0 to positive infinite, and again we have bracket. And this graph increasing on 0, positive infinite, and this one is not even and it's not odd, so neither even nor odd. Number 3, we have identity function. So what we have is f of x equal to x, and here is the graph that we have for this part based on this graph. Domain, what we have on x-axis, so domain starting from left to right. Here we have negative infinite, moving to right. So here we have arrow, that means that this straight line doesn't stop at this point but continues to negative infinite and positive infinite. So moving to the right side, we have positive infinite on x-axis, and range is same. So we have from negative infinite to positive infinite on top, and our graph increasing on negative infinite, positive infinite. And this is odd function. Here we have an absolute value function, f of x equal to absolute value of x. Here is graph. Based on what we have here, domain is, again, from left, we have negative infinite, moving to right, we have positive infinite on x-axis, and for range, what we have on y-axis, our graph starts from this point, and that point is equal to 0, so we have bracket, meaning that we have closed circle, so it's bracket 0, comma, on top we have positive infinite. And this graph decreasing on negative infinite, comma 0. So from left to right, this part decreasing from negative infinite up to this point, and then from this point 0 starts to increase, so increasing on 0 to positive infinite. And this is even function. Number 5, standard quadratic function. So in this part, our function f of x is equal to x squared, and here we have this graph. Based on this graph, our domain, so here again we have arrow. So arrow, that means our graph doesn't stop at this point, and what we're going to have for domain is negative infinite, because we can continue like this, goes to negative infinite, and on the right side we have positive infinite. So that is our domain. And range, starting from this point, we have 0 and it's equal to 0. So it's bracket 0, comma, on top on y-axis we have positive infinite. This graph again decreasing on negative infinite to 0 and increasing on 0, comma, positive infinite. Here again we have even function. Next one we have standard cubic function. So f of x is equal to x cubed. Domain again, because of having arrow. Domain, that means what we have on x-axis. From left to right we have negative infinite to positive infinite on the right side. And range is the same. So here we have negative infinite on top, positive infinite. This graph increasing on negative infinite, positive infinite, so it's increasing like this, and that is negative infinite to positive infinite. And here we have odd function. So this is odd function. Next one, cube root function. So f of x equal to cube root of x. Here our graph, we have arrow and domain. From left to right, what we have on x-axis, we have negative infinite. Going to right, we have positive infinite. And that is again same for range. So here we have negative infinite on top, positive infinite. And this graph increasing on negative infinite to positive infinite. And here again, we have odd function. Vertical shift, let f be a function and c positive real number. The graph of y equal to f of x plus c is the graph of y equal to f of x shifted c units vertically upward. Because of having this plus sign, this is upward. The graph of y equal to f of x minus c is the graph of y equal to f of x shifted c units vertically downward. But this one is downward because here we have subtraction and that is negative. So what we have here on this part, this is for y equal to f of x plus c. So the one that we have on this part, this is y equal to f of x, and we shifted this c units vertically upward because of having addition. And then what we have on right side, this is y equal to f of x. And what we have is y equal to f of x minus c. Because of having minus c, we have to shift f of x c units vertically downward. Here we have example, use the graph of f of x equal to absolute value of x to obtain the graph of g of x equal to absolute value of x minus c. So first we have to graph f of x equal to absolute value of x, and this is what we have. Remember that what we have for absolute value of x, any number that you use for absolute value, the result for f of x is always positive number. So here using 1, absolute value of 1 is 1. Absolute value of 2 is 2. Absolute value of 3 is 3. And that is same for what we have here on left side. Absolute value of negative 1, so you use negative 1 instead of x. Absolute value of negative 1 and positive 1. So what we have for y is positive 1. So we have negative 1, positive 1. That is the point that we have for this part. Then use x equal to negative 2. So absolute value of negative 2 is positive 2. We're going to have negative 2 comma positive 2 to find this point. And that is same for negative 3. So negative 3 instead of x, we're going to have f of negative 3 equal to absolute value of negative 3. And absolute value of negative 3 is positive 3. So this point is negative 3 comma positive 3. Then connect these points to graph f of x equal to absolute value of x, and then it's asking for g of x. Here we have minus 3, so because of having this negative sign, we have to shift this graph 3 units vertically downward. So it's 1, 2, 3, 1, 2, 3, 1, 2, 3. So shifting 3 units downward. Horizontal shift. Let f be a function and c a positive real number. The graph of y equal to f of x plus c. So here in this case, x plus c is what we have for our input. Is the graph of y equal to f of x shifted to the left c units. So here we have x plus c, and in that case, we have to shift to the left c units. So this is left y because we have our input is x plus c. If I try to find x so equal to 0, we're going to have x equal to negative c. So this negative, that means we have to shift to the left. Next one, the graph of y equal to f of x minus c. So here is our input. Is the graph of y equal to f of x shifted to the right c units. So for this one, what we have is x minus c equal to 0, x equal to c. So here we have positive. That means that we have to shift to the right. So this is our graph for y equal to f of x, and here in this case we have y equal to f of x plus c. So we have x plus c, that means we have to shift to the left c units. And the one that we have here on the right side, this one is for y equal to f of x minus c. The one in yellow, that is y equal to f of x, and what I have in green, that is y equal to f of x minus c. So because of having x minus c for our input, we have to shift f of x to the right c units. So all of the points that we have for y equal to f of x, shift all of them c units to the right. Example, use the graph of f of x equal to square root of x to obtain the graph of g of x equal to square root of x plus 4. So first we have to graph square root of x. This is what we have for square root of x. The point that I used here in this case, I used f of 0, square root of 0, that is 0. So here we have 0, 0. Then f of 1, it's square root of 1, that is 1. So what we have is 1, 1. F of 4, so square root of 4, that is 2. So what we have here is 4, 2. So for square root of x, I have these 3 points. So connect all these points and then use arrow to draw this graph. And then use that one to graph what we have for square root of x plus 4. So our input is x plus 4. We have this plus sign between. That means we can have x plus 4 equal to 0. So x is negative 4. We have to shift 4 units to the left. So we have 1, 2, 3, 4, shifted 4 units to the left, finding this point. From here, 1, 2, 3, 4, 4 units to the left. 1, 2, 3, 4. So we have 4 units to the left for all of these points. This is what we have for g of x equal to square root of x plus 4. Combine horizontal and vertical shifts. Example, use the graph of f of x equal to x squared to obtain the graph of h of x equal to x plus 1 squared minus 4. So the first point that we have here is f of x equal to x squared. So the points that I used for x are 0, 1, 2, -1, -2. So based on that, we have this point as 0, 0. We have 1, 1, because 1 squared is 1. Then 2 squared is 4. -1 squared is 1. -2 squared is 4. Then connect all these points to graph x squared based on this graph. Now, next step. So this is our first step. Second step is this one. G of x, for example, so in this case it was h of x. For second step, I used g of x. So g of x is equal to x plus 1 squared. I'm trying to graph this part. So we have x plus 1 here. That means we have x plus 1 equal to 0, x equal to -1. Because of having -1, we have to shift f of x 1 unit to the left. So here I had 0, 0. Shifting to the left, we're going to have -1, 0. We have -1, 1. Shifting 1 unit to the left, we're going to have -2, 1. We have 1, 1. Shift to the left, we're going to have this point. And that is this, on this part we have 0, 1. So do the same thing for what we have for -2, 4. Shifting 1 to the left, we're going to have -3, 4. Here we have 2, 4. Shifting 1 unit to the left, we will have this point, and that is 1, 4. And then next step, we're going to graph h of x equal to x plus 1 squared minus 4. So what we have in step 2, use this graph. And because of having -4, that means we have to shift our graph 4 units downward. So we have -1, 0. Shifting downward, we have 1, 2, 3, 4. We will have this point. Then 1, 2, 3, 4. 1, 2, 3, 4. So shift all these points. And our graph should be something like this. And I have this graph here on this part for h of x. So here are all 5 points that I have after shifting our graph 4 units downward. Then connect all of them, all of these points, and use arrow here on top. Next part, reflections of graphs. On this part, we have reflection above the x-axis, the graph of y equal to negative f of x is the graph of y equal to f of x reflected above the x-axis. Example, use the graph of f of x equal to cube roots of x to obtain the graph of g of x equal to negative cube roots of x. So graph gx reflect f above the x-axis. replace each y coordinate with its opposite. So here on this part first, I graphed f of x. I used the points that I have here, 0, 0, 8, 2. So cube roots of 8 is equal to 2. And cube roots of -8 is equal to -2. So we have -8, -2. We have 0, 0, and we have 8, 2. You can use more points if you don't know how to connect these points. Here in this case, we don't have a straight line. And because of having this cube roots, and then use that to graph g of x. The difference is that g of x has negative sign. So we have to reflect f of x above the x-axis. So what this means, mirror this part of graph to the other side of x-axis. So we're gonna have this one, which is here, and then this part of graph, mirror that to the other side of x. So we will have this, and this is what we have here on this part. So this is g of x equal to negative cube roots of x. Reflection above the y-axis. The graph of y equal to f of negative x is the graph of y equal to f of x reflected above the y-axis. So the difference between this and what we had on top is that this negative is here inside as input. For each point x, y on the graph of y equal to f of x, the point negative x, y is on the graph of y equal to f of negative x. So here we have negative x, that is our input, and that is same on this part. Example, use the graph of f of x equal to square root of x to obtain the graph of h of x equal to square root of negative x. So graph h of x equal to square root of negative x, reflect f above the y-axis, replace each x coordinate with its opposite. So what we have, this one is f of x equal to square root of x, and the point that I used are 0, 1, 4 for x, and find y, or find f of x. So square root of 0 is 0. We have 0, 0, which is that point. Square root of 1 is 1, so we have 1, 1. Square root of 4 is 2, so we have 4, 2. And then, using what we have for f of x, graph h of x, which is equal to square root of negative x. What we have to do is that mirror this graph to the other side of y-axis, because this one is above the y-axis. Reflect f above the y-axis, or mirror this part of graph to the other side of y-axis. So that means this is what we have for hx. So what we have for h of x equal to square root of negative x. Vertically stretching and shrinking graphs, let f be a function and c a positive real number. If c greater than 1, then graph of y equal to c times f of x is the graph of y equal to f of x vertically stretched by multiplying each of its y coordinates by c. If c between 0 1, the graph of y equal to c times f of x is the graph of y equal to f of x vertically shrunk by multiplying each of its y coordinates by c. So what we have here on this part is this one is y equal to f of x, and this is when c is greater than 1. So we have to use graph of y equal to f of x and vertically stretch by multiplying each of its y coordinates by c. So multiplying by c, we're going to have this graph. So stretching it, this will be graph for y equal to c times f of x. So c times f of x is narrower than f of x. And what we have here on right side, this is y equal to f of x. And here in this case, c between 0 and 1. Our graph f of x vertically shrunk by multiplying each of its y coordinates by c. So this one shrunk, and this is what we have for c times f of x. And c times f of x is wider than f of x. Example, use the graph of f of x equal to x cubed to obtain the graph of h of x equal to 1 over 2 times x cubed. So what we have here on this part, our c is equal to 1 over 2, and that is between 0 and 1. So what we have to do is that vertically shrink the graph of f, because c is between 0 and 1, multiply each y coordinates by c, and c is 1 over 2. So first we have this graph for f of x equal to x cubed. I used 0 cubed, that is 0, so the point that I have is 0, 0. Then I used 2 cubed, that is 8. We can have more points. So for example, 1 cubed is 1, so this is 1 comma 1. Here at this point, negative 1 cubed is negative 1, so that is negative 1 comma negative 1. And then we have negative 2 cubed, that is negative 8, so we have negative 2 comma negative 8. Now graphing what we have for h of x, that is equal to 1 over 2 times x cubed. So multiply each y coordinate by 1 over 2. Y coordinate, what we have here on this part is 8. So 8 times 1 over 2, that is equal to 4. This is how I got this point. So we have same number for x, but changing y to 4. The next one we have 1 comma 1. So 1 times 1 over 2, we're going to have 1 over 2 for y. So what we have here, this point is 1 comma 1 over 2. Here we have 0, 0. Here at this point we have negative 1 comma negative 1 over 2. And this point is negative 2 comma negative 4, because that is negative 8. The one that I have here, negative 8 times 1 over 2, so that is negative 4. And for that part we had negative 1 times 1 over 2, so that is negative 1 over 2. But the point that we have here is negative 1 comma negative 1 over 2. And then connect all these points, use arrow, and the graph that we have for h of x, that is wider than f of x. Now this part we have horizontally stretching and shrinking graphs. Let f be a function and c a positive real number. If c greater than 1, the graph of y equal to f of cx. So in this case, instead of having c times f of x, we have f of c times x. The graph of y equal to f of x horizontally, so instead of vertically, we have horizontally shrunk by dividing. So here, instead of multiplying, we have dividing. These are the differences between what we have here and what we have for vertically. So dividing each of its x coordinate, so instead of y we have x. So dividing each of its x coordinate by c. If c between 0 and 1, the graph of y equal to f of c times x is the graph of y equal to f of x, horizontally stretched by dividing each of its x coordinate by c. So what we have here on the spot is when c is greater than 1. Here we have y equal to f of x. Because of having c greater than 1, using graph of y equal to f of x, we have to shrunk f of x horizontally by dividing each of its x coordinate by c. So that means, so after dividing, we're going to have y equal to f of cx. This one in green. And here on the right side, now we have c between 0 and 1. And this is what we have for y equal to f of x. Using y equal to f of x horizontally stretched by dividing each of its x coordinate by c. So here in this case we have to stretch f of x horizontally by dividing each of its x coordinate by c, and we're going to have this one, which is f of c times x. So the difference between these two is that the one that we had for c greater than 1, this is narrower than f of x. So y equal to f of cx is narrower than f of x. And here on the right side, when c is between 0 and 1, y equal to f of cx is wider than f of x. Example, use the graph of y equal to f of x in the following figure to obtain each of the following graphs. So here, this is what is given. And we have these points, negative 4, 0, negative 2, 4. This one is 0, 0. We have 2, negative 2, and we have 4, 0. So using what is given here on this part, we want to graph g of x equal to f of 2 times x. So divide each x coordinate by 2, because here in this case c is equal to 2 and that is greater than 1. So what we're gonna have using x coordinate, we have here we have 4, 2, here we have 0, negative 2, negative 4. So divide all these numbers. So this is 0, 0. All these numbers by 2. Starting from this point, we have 4 divided by 2, that is 2. Then we have 2 divided by 2, it is 1. 0 divided by 2 is 0, so we have 0, 0 on this part. And then negative 2 divided by 2, we have negative 1. Negative 4 divided by 2, we have negative 2. So these are what we have for x coordinate, and our y coordinate will not change for all these points. Then connect these points to graph g of x. Then what we have here on the right side is this is h of x, that is equal to f of 1 over 2 times x, and here in this case c is 1 over 2, and that is between 0 and 1. So use the points that we have for x-axis from the one that is given here on top. And then, so we have 4, starting from this point, we have 4 divided by 1 over 2, so it's 4 multiplied by, use reciprocal of what we have here, that is 2 over 1, so this is 8. So what we have here on this part is 8. Then we have positive 2, so it's 2 divided by 1 over 2, or 2 multiplied by 2, so that is 4. This is how I got this x coordinate. 0 divided by 1 over 2, or 0 times 2, that is 0. So here we have 0, 0. Then we have negative 2. So to find this part, it's negative 2 divided by 1 over 2, or negative 2 times reciprocal, that is 2 over 1. So this is negative 4 over 1, or negative 4. And the last one that we have here on this part, it's using what we have on this part is negative 4. So negative 4 divided by 1 over 2, that is negative 4 times 2 over 1, and that is negative 8. So this is how I got negative 8. And what we have for y coordinate, these numbers will not change. And then finally connect these points to graph h of x. Just remember that you have to do exactly the same as what is given. This one is not a straight line, so we're not going to have a straight line. This one, this part is a straight line, so here I have a straight line. So here again, this is not a straight line, that's why I do not have a straight line. And that is same for what we had in part A. So this is not a straight line, so this part is not a straight line, but here we have straight line. So for part A, f of 2x is narrower than f of x, but for part B, f of 1 over 2 times x, that is wider than what we had for f of x. Order of transformations. A function involving more than one transformation can be graphed by performing transformations in the following order. The first one, horizontal shifting. Second, stretching or shrinking. Third one, reflecting. And fourth, vertical shifting. Example, use the graph of y equal to f of x given in the figure below. So this is what we have for y equal to f of x. To use that to graph y equal to negative 1 over 2 times f of x minus 1 plus 3. So first, I'm going to graph this part. So that is our first step, which is this one. And what we have to do, because of having x minus 1, that means we have to shift our graph 1 unit to the right. So add 1 to each x coordinate. So here we have 0, 0, we're going to have 1, 0. Here we have 2, negative 2, we're going to have use this x coordinate to add 1. So we're going to have 2 plus 1, and that is 3. So we will have 3 comma negative 2. So do same thing for all these points to find these that we have here, and then connect them to graph f of x minus 1. And then I multiplied what I had here by positive 1 over 2. What that means, this graph, we have to shrink vertically and multiply each y coordinate by 1 over 2. So multiply each y by 1 over 2. Here we have negative 3, comma 0. So use y coordinates. So using all these, we have 0, 4, 0, negative 2, 0, multiply by 1 over 2 to find what we have here. So here we have 0 times 1 over 2 is 0. Here we have 4 times 1 over 2 is 2. Then we have 0 times 1 over 2 is 0. Then we have negative 2 times 1 over 2 is negative 1. 0 times 1 over 2 is 0. And then connect all these points. On this part we had positive 1 over 2, but here in this case we have negative 1 over 2. So next step is graphing y equal to negative 1 over 2 times f of x minus 1. So use the points that we had here on this step, and then reflect all those points above the x-axis, meaning that replace each y-coordinate with its opposite. So here on top we have negative 3, 0. We're going to have negative 3, 0, and then we have negative 1, positive 2. We have positive 2 for y-axis. Multiply that by negative, we will have negative 2. So this one is negative 1, negative 2. Here we have 1, comma 0. 0 times negative is 0. Here we have negative 1 times negative, we will have 1. So the point that we have here is a 3, comma 1. Here we have 5, 0, 0 times negative, again is 0. And then connect all these points. Then finally, graphing y equal to negative 1 over 2 times f of x minus 1 plus 3. So use what we had here and then shift our graph 3 units upward because of having this positive sign. So shifting 3 units upward. Find the points and then connect them to a graph. So this is our final answer. This one is our final graph for our function.